So this workshop is on solving systems of equations using elimination. So the last workshop you viewed was on solving by substitution. And when you solve by substitution, it's not too hard to conceptualize. You just solve for a variable, and then you solve for one variable in terms of the other, and you plug in your result, and you solve for the other variable. But it gets messy. It's a lot of work sometimes. When you solve by elimination, it's kind of the opposite. You end up with a type of problem that is sometimes really easy to solve and kind of harder to conceptualize how it's working. So we're going to solve this system here by elimination. So when you solve by elimination, what you do is you strategically combine the two equations in order to eliminate a variable. So here I notice in the top equation I have a minus y. In the bottom equation I have a plus y. So I'm going to add these two equations together because those y's are going to cancel out. So I have the entire equation, x minus y equals 11, and I'm going to add it to 2x plus y equals 19. And I just add, I combine the like terms, so x plus 2x makes 3x. Y plus negative y, well, those cancel out, and I'm left with nothing. And then 19 plus 11 is 30. And just like magic, my y is gone, and I can solve for x. Divide both sides by 3, and we have x equals 10. And the second part of solving a system by elimination is the same as if you solve by substitution. You plug one variable in and solve for another. So I'm going to plug my x equals 10 in. X equals 10. I'm going to plug that in for x now and solve for y. So 2 times 10 plus y equals 19, which means 20 plus y is 19, and y equals negative 1. So the solution to this system is 10, negative 1. Now, a lot of you at this point are probably like, why can you do this? Because you're always told you've got to add the same thing to both sides, right? And we didn't add the same thing to both sides. We added 2x plus y on one side, but we added 19 to the other side. Like, why do we get to do that? And it's because even though we added a different, on one side we added 2x plus y, and the other side we added 19, those two things are equal. It's like if we added a half on this side and 0.5 on the right side. A half equals 0.5, so we didn't change anything. So since 2x plus y equals 19 in this problem, then we can add 2x plus y to one side and 19 to the other side. Those two things are equal, right? So it almost feels like we cheated when we solved that, right? Let's do another one. We have negative 4x plus 9y equals, oh, that's a magic pen. Negative 4x plus 9y, that's pretty cool, equals 9, and x minus 3y equals negative 6. So in this one, I don't immediately have a positive x and a negative x, or positive y, negative y on the top and bottom. But I notice if I take the entire top equation, or the entire bottom equation, and I multiply it by and I multiply it by 4, then I would have a positive 4x, which would cancel with my negative 4x. I can also multiply it by 3 to get a positive 9y. So I'm going to take the entire top equation and multiply the whole thing by 4. So 4 times x minus 3y. And on the other side, I would multiply it by 4 and get 4 times negative 6. So now my new equation is 4x minus 12y equals negative 24. And this was taking the bottom equation and multiplying it by 4. Now I'm going to add the other equation, so plus negative 4x plus 9y equals 9. Now when I add the two equations together, my x's are going to be eliminated. So I eliminate the two x's, and then I just combine. So negative 12y plus 9y gives me negative 3y, and negative 24 plus 9 gives me negative 15. So negative 3y equals negative 15, and y equals 5. Then we just take our y and plug it back in, so x minus 3 times 5. I'm using the second equation here just because it looks easier. So then x minus 15 equals negative 6. Add 15 to both sides. You get x equals nine, right? Yeah, x equals 9. So then our answer here, the point where the two lines intersect, would be at 9, 5. So let's keep going. Let's do an example where we have to change some signs around. So say we had negative 3x plus 7y equals negative 16, and negative 9x plus 5y equals positive 16. Now, here I see that 3 is, it's easy, I know I can multiply the top equation by 3 to get it to a 9x. With this second one, there's not a, I would have to multiply both equations or multiply by something, by some fraction. So it's going to be easier to work with the x in this scenario. But they're both negative, so I'm not going to multiply the top by negative, or by 3. I need to multiply the top equation by negative 3. So negative 3 times negative 3x plus 7y, and negative 3 times negative 16. So now my new top equation is positive 9x minus 21y and equals positive 48. And I'm going to add this to the bottom equation. So minus 9x plus 5y equals 16. And then again, I combine straight down. My 9x's go away. This becomes 16y. 16y equals 48 plus 16 is 64. Oh, that's a negative 16y. Divide both sides by negative 16. Right, this was negative 21y plus 5y, negative 16y. So then y equals negative 4. And again, I just take my negative 4, I plug it into something. Neither of these equations is, well, they're not hard to work with, but there's not an easier one, obviously. So I'm going to take the top one. So we have negative 3x plus 7 times negative 4 equals negative 16. So negative 3x minus 28 equals negative 16. Add 28 to both sides. So then negative 3x equals negative 12, positive 12. That's a negative 16 plus a 28, so that becomes a positive 12. Divide both sides by negative 3. We get x equals negative 4. So our solution in this one is negative 4, negative 4. That's where the two lines intersect. So the real trick in solving by elimination is just recognizing which variable is easier to eliminate. So in this one, if we had tried to eliminate the y's, like I mentioned earlier, you would have to multiply the bottom equation by 7 and the top one by 5. That would be one way to do it. You could do it. It would be a little trickier. And at that point, you notice that the x, one is a multiple of the other, like 3 times 3 equals 9 exactly. then picking the easier variable to work with is the most important part of solving by elimination. Okay, so that concludes this workshop. A final note on choosing substitution and elimination. It's really, really good if you're comfortable with both ways to solve a system of equations, because some equations are really a lot easier to solve by substitution and some are a lot easier to solve by elimination. Now, they can both be solved, or all systems of equations can be solved with either method, but if you know which method to use at which time, then you're going to save yourself a lot of trouble. All right?